So here I'm looking at the JK flip-flop that's built from a D flip-flop. So I had to add something in here because once again Logicin was giving me a little bit of crap because of these these NOR gates, or I guess in these cases they're OR gates that are connected. And what I had to do, excuse me, what I had to do is I had to add this device here called a controlled buffer, or it's a tri-state gate. And what this does is when its input is a 0, it's like this OR gate isn't even connected to the output. It's like it's not connected at all, meaning that it's not outputting a 0 or a 1. It's floating. There's nothing to drive it. And so that allows this pull down resistor, right? It's pulling down to a 0, even though it's on the upwards direction. It's pulling down to 0. And this 0 causes the kind of latch to jumpstart where Q equals 0. And so these are, what this does is temporarily disconnects the output and allows it to start at 0. And when I'm ready to start the simulation, I just have to enable it. And so now I've got it enabled. That means that this this signal is a 1, and what that means is this OR gate can now connect to this output here. And you can see the D flip-flop is built out of D latches, and that initialized signal just kind of branches out all the way to here. So now we've got the device enabled and it's ready to rock and roll. This is, once again, that was all just so we could get away with the fact that we're simulating things here, and the simulation is ideal, and really these devices actually depend on a little bit of randomness to work fully properly. So anyway, let's see if this has, or what kind of behavior this has. So we can kind of think of the J as an S input of the SR latch, or that's going to set, and K as our reset, and then of course our clock here. And if we use a D latch, or sorry, a D flip-flop to make a JK flip-flop, we actually have an edge-triggered device because the D latch is edge-triggered. Sorry, the D flip-flop is edge-triggered. So we know that when both of our set and reset, or in this case our J and K inputs, are both 0, nothing should happen, and nothing does happen. And if we want to set it, we set J to a 1, and so here we see that our input to our D flip-flop is a 1, and so that means on the next rising edge we're going to write a 1 to our D flip-flop. And there we go, our output is a 1. And just to show that it's edge triggered, right, I can move these guys around and nothing happens, right? It's not level triggered, it's edge triggered. Now we're gonna go back down to a clock down to a 0, and now this time let's clear it. And yep, we cleared it. We wrote a 0 to our flip-flop. And finally, let's try our toggle state where both J and K are 1. And so what we should expect is we're going to take the opposite of Q, which is coming around here, and it's writing a 1. So we have a positive edge and we wrote a 1. Now I've got a 0 coming around, we're going to write a 0. And so we're able to toggle, right? It just keeps on flipping back and forth forever, which is actually something that we can use later to make something called a T flip-flop, which is used for toggling, hence the T.